Problem 10 in the homework picks up where the application that we did in class leaves off. So here we have the same sludge, oil, and Northwest lumber problem. City Council wants to curb emissions by half, but they're going to do it by auctioning off 4 permits this time. And the way we're going to think about it is, what if they started auctioning with a low price of $1 and raised the price until the quantity demanded dropped from 8 that would be demanded at a low price of 1 to just 4. Anyway, so let's think about that. We have to remember that the logic of the firm will buy a permit if buying a permit is cheaper than cleaning up. The firm will clean up if cleaning up is cheaper than buying a permit. So at $1, nobody would clean up because you remember that you have to figure out marginal cost of cleanup. So for sludge, costs 20 to clean up 1 ton, costs another additional 50 to clean up a second ton, and it costs 80 to clean a third ton. I guess for completeness, 300 to clean up that 4th ton of pollution. Notice that we're moving from process A to process B to process C to process D to process E as we clean up. Northwest lumber cost them 80 to clean up 1, 320 to clean up that second ton, 500 to clean up a third ton, and 1,000 to clean up a 4th ton. All right, so if we think about that auction, we can see $1, $2, $3, $4, $5, $6, $7, $8 no cleanup would happen. Only when the permit price got to be higher than 20. So 21. At $20 permit price, sludge would flip a coin about whether to buy a permit or to clean up. But at 21, it'd definitely clean up a ton. So at 21, 1 ton is cleaned up, so permit demand is down to 7. Well, at 7, we need to keep raising it till quantity of permits demand is down to 4. And that's the same as saying until the cleanup is 4. All right. The reason those two numbers is the same is that total cleanup minus the number of permits sold is equal to the units of pollution that have to be cleaned up. These are both equal to 4 because we're going from 8 down to 4, but there's a later problem where you're going from 10 down to 2 or something like that, where you'll see that distinction a little more clearly. Anyway, 20 isn't going to do it. 21, if price of a permit at auction got up to 51, we'd see sludge would definitely clean up a 2nd ton of pollution, but that's it. There's going to be 6 permits demanded at a price of 51. Well, that's not high enough. We have to raise the price, and 51's at 52, 53, 54. Not until it gets up to 81 would sludge clean up a 3rd ton, and would Northwest lumber clean up a 1st ton. And at a price of 81, that gets us to where we need to be. Sludge cleans up 1, 2, 3. Northwest cleans up 1 ton. So that's our answer. That's the more important. That's our thinking process. Each permit will then sell for 81. How many permits will each firm buy? Well, notice that sludge is cleaning up 1, 2, 3. You only need a permit if you're going to emit a ton of pollution. Sludge is only emitting 1 ton, so they only need 1 permit. Northwest is cleaning up 1 ton, and that leaves it demanding 1, 2, 3 permits. And the total cost to society of this program, notice that sludge's costs go from 50 to 200, so that's 150. And Northwest costs go from 100 to 180, so that's 80. Add those together, you get 230, and that's your answer. The cost of cleaning up the pollution is 230, which, remember, you calculated that cost to the 50-50 assignment of pollution reduction, the command and control, where both had to adopt process C, and that cost was $470, as I recall. So this is substantially less cost, and we get the same amount of pollution cleaned up. So this is an important type of problem to see how that change from a command and control to a incentive-based regulation can really reduce cleanup costs without reducing the benefits of pollution cleanup at all, as long as we're talking a regional or a global pollutant.